This process is known as the heat treatment procedure, aimed at enhancing the forgeability of a material by achieving a more uniform microstructure. This involves subjecting the material to controlled heating and cooling cycles in order to modify its internal crystalline arrangement, making it more consistent and thereby improving its overall workability and formability during subsequent forging processes. This heat treatment step is crucial in optimizing the material's mechanical properties and ensuring its suitability for specific applications. In the forging process, lubrication treatment is employed to reduce friction between the mold and the material, thereby preventing adhesion or sticking. This treatment involves applying a lubricating substance or coating to the surfaces of the mold and the material being forged. The lubricant serves as a barrier between the two surfaces, allowing for smoother movement and shaping during the forging process. Additionally, it helps to dissipate heat generated by the friction, which can contribute to the overall efficiency and quality of the forging operation. Preventing excessive friction and adhesion is crucial in achieving precise and consistent results in the final forged product.